So this is a remote controlled competitive combat robot. This is our senior design project for me, Darren Jackson, the computer engineer.
Me, Michael Cavaluzzi, the electrical engineer.
Brandon Davenport, a mechanical engineer.
And James Schramm, the other mechanical engineer.
So our project is to design and construct a combat robot to compete in a combat robot tournament in Norwalk, Connecticut. The main problem that we're going to be facing with constructing this combat robot is that it has to be less than 3 pounds and have enough power to run for 3 minutes. It also must be able to move swiftly, inflict damage on other robots, and be equipped with sufficient defense. It also has to be controlled easily. To accomplish this, we have to choose the lightest components and materials that are yet still durable enough to withstand impacts.
This project has a set of known constraints and specifications, either set forth by the tournament itself or the school. So in terms of specifications, we have what kind of materials we're using, the quantity and types of motors, different speed controllers, the geometry and amount of wheels needed, a feasible power source to power the entire bot, and combat equipment for the actual combat. And then in terms of constraints, as mentioned previously, the maximum weight has to be either 3 pounds or lower. We are allowed to use modular bots that can have a max of 50% of the weight exchanged in between battles. The bot itself needs to be fit into a 30 by 30 by 24 inch cube before each fight in its final form. The maximum voltage for the entire circuit has to be either 60 volts or less. And a requirement set by the school is we have a $200 budget.
So a crucial principle that we'll be using is pulse width modulation. We'll be using that to control the motors. It requires a voltage source to run high then low at such a high frequency that the current actually remains steady. Within one period, if the signal is on for 50% of the time, an output of 50% voltage will be achieved. If the voltage is on for 75% of the time, then an output of 75% of the signal source voltage will occur. This allows for precise control of the motor speed.
In order to begin spinning the wheels, a certain amount of torque is required. So a motor was selected with a sufficient stall torque so that 2 of these motors combined will not stall when initiating wheel spin.
So the power supply has to have a sufficient capacity in order to power all the components for the 3-minute battle. The current draw from each device was calculated and added up to determine this capacity.
A careful analysis is needed for each component to determine the material, dimensions, weight, and placement. Like mentioned earlier, there are torques that need to be calculated for this, as well as moments of inertia, centers of mass, stress, strain, and many other things.
Due to time constraints, a temporary remote control is being used in order to determine how the robot functions. This will allow for furthering of the project in other fields and help work out some of the functions of remote control interaction when the actual remote control is complete.
We had to change our microcontroller because of compatibility issues. We switched from the STM board over to Arduino because we found it to be a lot easier to connect to our motor drivers and the Bluetooth. We also found out that it's important to choose schematics or components with schematics, because if they don't, it is easy to fry your components.
Experimenting with the prototype will give insight into whether the dimensions, placement, and calculations chosen and made are accurate, or if they need changes or upgrades. There will be a focus on building several versions of this prototype after experimenting with the original and future draft versions. In addition, effort will be focused on developing and applying the robot's combat equipment. And as more data is collected on mechanical and electrical stresses, revisions will be necessary to move on to a final version. An additional goal for this spring will be a remote control through a smartphone app.
Here you can see a 3D model of the prototype that we're designing. And you could also see an actual prototype mapped out with all our components and our walls, our wheels, and our combat equipment. So we will end up using all our previous knowledge and skills that we've learned through over the years, and we'll also use those that we've learned throughout this project to create the best possible BattleBot. This project provides an excellent opportunity to develop our ability to work as a team to meet goals and deadlines. And the overall goal is to be able to design a BattleBot capable of winning this tournament.